Okay, so picking up right where we left off in this video, what we're going to do, we're going to make the bottom portion of the ship be destructible. So to make that happen, we need to do two things. One, we need to apply a box collider. What that does, as the name suggests, it detects collisions. It in of itself does not do anything other than detect the collision. In other words, it doesn't do anything with that information, which leads us to the second thing we need to do. We're going to apply a script that says what to do when a collision occurs. So let's just go ahead and select these objects. And just to make sure we got them all, you can just move the arrow. We do. Now, I technically could have applied the box collider before I started. In this case, really doesn't make much of a difference, but generally best practice, if you're going to have an object basically be a template for a bunch of more objects, and that is you're going to copy it, and you want all those objects to have the same functionality, it's best to put that functionality in place first. Not a big deal because there's only about 15 or 16 of these, so it's easy enough to apply it. But I just wanted to say that you would really want to do that, though. You really want to apply everything first, all the components first, and then start copying it. Having said that, I really didn't want to distract from the assembly of the object. So in this case, not a big deal. Anyway, so add component, physics 2D, make sure it's the 2D, I know I keep saying that, box collider. So just like that, you fixed it. They all have colliders. But you can see there's a bit of a gap here. I wouldn't worry too much about it because this particular ship, if we're copying the arcade game, it moves down vertically. So it's not like as if this is going to cause a collision that wouldn't happen. It's just happened a millisecond sooner. So if you want, you actually could click on, say, Edit Collider, and then you could shrink these in a little bit. If you want to. Not a big deal. So just want to let you know. But if you had shrunk in the first one and then you copied it, then you wouldn't have to fix all these. So again, you really want all those components and all that functionality, all that customization in place first before you start copying. There's one exception that we'll get to because there is one thing that we have to do per object that really can't be copied. Okay, so we added the box collider. Actually, let's do one more thing. Let's go back to our box colliders, or our objects rather. We're going to turn those colliders into triggers because we don't want these to be solid. We don't want hard collisions to happen. Okay, so all our objects have box colliders. Now what we're going to do, we are going to add a script that then says what to do when a collision occurs. So let's right-click, create C#, and we'll call this base con because it's going to control the base object. Now, if you attach a script to, say, 2 or 2,000 objects, if you make a change to that script, that source script, the change cascades to all the other objects because they're all pointing to the same script. You don't have 2,000 instances of the script. They're all pointing back to the same script. In other words, you change one script and it goes out to all the objects that it's attached to. So what we'll do is we'll take our base again. So they're all selected. Move this again, make sure they're all selected. And we'll take our base con script and attach it. So now they all have it. And again, if I make a change to the script, it will change every single one of these. Because again, they're all referencing back to the single same script. So let's go ahead and open that up. If you see this double / that tells you it's a remark. So that means it's not executed. It's internal documentation only. So you can get rid of those. Feel free to add your own documentation if you want. And that's just a double / if you're going to do that. So now what we need to do, as I said, the key to this is the Y scale, the scale along the Y axis, because that determines how many times it can be hit. So we're going to create a variable. So public float, since it's going to be using decimals, and we'll just call it Y scale. We'll have it default to 1. However, this is what I was talking about. Since the different objects have different Y scales, we will have to manually change those, and there's really no way around that. With a little coding, we probably could, but it's not a big deal. So what we now say is on trigger enter 2D again. Use the 2D. And the other stuff pre-populated because this is Microsoft Visual Studio, and that's one thing it does for you. As I've mentioned before, I don't like the fact that it puts collision here because it makes it sound like it's an additional function when in fact this word is referring to the other object involved in the collision. So this script is attached to the base. It's detecting a collision with another object. That's what other is referring to, that other object. So if, oops. So if other dot tag, we'll get to in a minute what tags are, equals, double equals, by the way, shot, then we want something to happen. We want that y scale minus equals 0.1f, and then we apply it to the object the script is attached to. So get component, transform capital T, local scale, equals new vector 2 because we're only looking at the x and y scale, not looking at z because it's 2D. So the x scale should stay the same at 1, but y should be the y scale variable. So as this gets reduced, so as that variable gets reduced and it gets applied to the scale of this object, the object will therefore shrink. So let's go ahead and save that, and then I'll walk through this a little bit more. Okay, so one of the ways of identifying an object is by a tag. A tag is just a text field that can be referenced. So what we're going to do, we're kind of thinking ahead here. We're like, okay, we only want these base objects to be damaged if it's hit by a player shot. So how are we going to know that it's the player shot? When we create the player shot object, we'll add a tag called shot. Now, no real way to test this because we haven't created the player shot yet, but I think that will be the next thing that we do. Actually, one more thing. So, one at a time, you click on these objects, and what we need to do is we need its vertical scale to match. So, excuse me, we need the y scale variable to match its actual y scale, its y axis scale. So rather than being 1, this should be 0.01. This one is 0.3, so this should be 0.3. This one is 0.5, so the y scale should be 0.5. Same for this one, same size. 0.7, 0.7. Oops, 0.8. Sorry, the last one was 0.7. Okay. These three should be fine because these are 1 to begin with, and now you just do the same thing here. So let's go ahead and make the player ship the player shot, and then that will take care of most of the functionality because that will then prove whether or not these can be damaged. Now, we don't have one that destroys it because if it's at point 1, it gets hit again, then it will destroy it. So we do need one more line in there that says if point 1, if 0, whatever, then destroy this. So let's get the player in here first. So we'll take the ship object, just drag and drop it. Technically, it needs a collider for if the alien ship is firing back. In Phoenix, there were like ships that were coming down as well as shooting down at you. I probably won't go that far because this is really just about making a destructible ship, but I'll add other things to this if you want to see it. So for now, for the ship, we'll go to Physics 2D. We will go to Rigid Body 2D. We'll get rid of gravity. That now allows for the application of velocity as well as physics in general, such as gravity. So now we need a script for that ship. So right-click, create, C#, and we will call this player ship. We'll click on the ship. We'll put player ship on it, and we open up that script. So we're open to player ship. Again, we can get rid of this. This is a remark statement, is not executed. Now for here in the update section, what we want to do is we want to detect if a key is pressed. We'll just use the space key. You can use a controller if you want, mouse, whatever, it doesn't matter. Space is just easy to code and easy to make sure you're actually hitting the right button. So if we're looking for input, so if input dot get key down, and I mentioned in the Garf video as well too, the difference between get key and get key down. Get key down is true just once the first frame that the button is pressed. Get key is true for every frame that is pushed. So the difference, get key down is a manual shot, where get key is automatic. It's rapid fire. There's lots of other applications, but generally speaking, if you're thinking about a weapon, then that's what it is. One is a manual shot, one is an automatic shot. So if the space is pressed, we want something to happen. Well, we want an object to be instantiated, so that means we're going to have to create a shot object, but we can put that into here first. So public transform, and we'll call it bullet obj, because the obj is completely optional. I just like to use that suffix. That way when I see this pre-populating in a list, I know that it's an object. All right, so what we need to do, we'll come back to here. So our ship is selected, and you now see this bullet object. So let's take a second to create the bullet object. So unfortunately, I kind of did this a little bit out of order. So we'll click on our box solid, go to game object, 2D object, sprite, call this shot. Now we'll do a couple of things. We will make this not as wide. And maybe that's a fine length. Okay. And then what we'll do, we'll add a box collider to it. So physics 2D box collider. That way the base objects can detect the collision. It too will be a trigger. It too needs a rigid body, so we can apply velocity to it. we will again shut off gravity. And that gives us our shot object. So we'll put it here, delete it from the scene. So by putting it here, it makes it into what's known as a prefab. We go back to our ship, so it's looking for the shot object. So there's the shot object. We'll go back to our script. So what we're saying is if the space button is pressed down, then instantiate. So instantiate has, when you hear instantiate, think spawn. When you think spawn, think instantiate. The words are interchangeable. From a coding point of view, you have to use instantiate, but that's the technical term when you're thinking of an object being spawned. So instantiate has 3 arguments: what's being instantiated, where it's being instantiated, and the rotation of the object. So what's being instantiated, we said that is bullet obj. Where it's being instantiated, well, we want it to be instantiated just above the ship. So if you want it to be instantiated exactly where the ship is, you could just do transform.position. But the Y needs to be higher, it needs to be above the ship. So we will do new vector 2. So transform.position.x, transform.position.y, and we said we want it to be above it, so we'll do +1. And bullet object dot rotation. Okay, so let's break this down. I said that there's 3 arguments: what's being instantiated, where it's being instantiated, and the rotation of it when it's instantiated. So this whole big mess in here is really just giving you the coordinates. Again, the x coordinate of the script of the object the script is attached to, the y coordinate of the object the script is attached to, +1, so it's above the ship. Okay, so that should actually be everything that we need for the ship other than movement. So just one more thing, the bullet isn't actually moving yet, so we need to add a script to this. So right click, create C#, and we'll call this bullet con for control. Grab our shot, open prefab, drag and drop it there. And all this is going to do is give us velocity. So when it's instantiated, that's the start section. Just get component, rigid body, 2D, and it is velocity equals new vector 2. It's not moving on X, but it's moving on Y. It'll give it like a 2 velocity. Again, this is attached to the bullet, so it's only affecting the bullet. So I think that's everything that we need to make the bullet fire. We do need to add the tag. So add tag, and we said the tag was going to be shot for the bullet. It's important to note that when you click on add tag, you're creating a new tag. You haven't actually applied it. You have to come back and then apply it. So the bullet now has the shot tag on it. So what should happen is when I press the space button, so let's walk through this. So here's the player ship. When I press the space button, this should get instantiated. Well, this has velocity to move it vertically upwards. And then this will check to see if a collision has occurred. So it all ties together. So let's hit space. Excellent. Now, a few things. It kept going, so I actually made one mistake. I said that nothing else has to be done to the shot. We actually do have to do one more thing to the shot. We have to have it self-destruct. So bullet So we're in the bullet con script, outside of start, outside of update. Again, on trigger enter, this should look familiar now. We just did this. And we'll just, you would want to make sure it only gets destroyed with certain collisions, but right now the only collision that can occur is with the base of the ship. So we'll just do destroy game object. So this script again is attached to the bullet. So when it collides with a trigger, it will self-destruct. By the way, I'm not going to do it here, but with the destroy command, you can actually add a timer. So like you could do this and then add a few seconds. Why would you do that? Landmine, some kind of tripwire. So you don't want it to destroy. You don't want it to detonate right away. There we go. And see how it only pushed it in? It didn't like destroy the whole thing. It actually scaled it vertically upwards, which is exactly what we wanted. And even though it wasn't in the other game, you could do something like you could do a little flourish, like you could have a little particle system, spew out here. So I'll see what kind of response there is to this video. If you want to see a few bells and whistles like that, just let me know and I'll do a third video. But for the moment, I think this is just about everything I want to do, but I will show you how to do the motion on this ship. So, player ship con. So we check for space. We're going to check for A and D. So typical WASD control. So if input dot get key, and here we'll use get key, not get key down, because if you're moving left and right, you don't want to have to hit A. No, you want to hold A. So here's an example where you want it to continually check for movement. So get key, A. So if A is being pressed, we want something to happen. Well, get component. And yes, someone out there is going to say that using get component this much is not the best way to do it because it is resource intensive. That is completely true. However, this is not a resource intensive game. Therefore, you've got plenty of leeway to do it this way. And I think this is a much easier way to explain than some of the other ways. So get component, rigid body 2D. Just like we did with the bullet, velocity. Vector 2, but in this case, we are moving it along the x-axis in the negative direction. It's moving left. It's not moving up. Now we're going to copy and paste this for two reasons. One, because I am extremely lazy. B, it's important to realize that this isn't new functionality. It's the same thing. Now it's the D key, and it's a positive 2. So just like on the keyboard, one is left, one is right. This is moving left, this is moving right. Now the thing is, what this doesn't do is it doesn't stop you when you let go of the button. It simply says, is the button being pressed? You need a command that says, well, what happens if the button isn't being pressed? So what we can do is we connect these two with an else. So it checks to see if you're moving left. If it are, great, keep moving left. What if you're not moving left? Well, let's see if you're moving right. You are, great. But what if you're not moving right? And here we say if, and then you do an exclamation point, as ridiculous as it looks. The exclamation point means not in C#. So not this, not that, not equal. So if you're not getting input, get key A. And oops, why did that happen? And not getting input, get key D, and then the whole thing has to be in parentheses. And this is another nice little thing that Visual Studio does is when you have a parenthesis selected, it shows you in gray the matching one. So particularly with an if statement, this is really helpful because you have to make sure you have exactly the right parentheses. And inputs make it even a little bit crazier because the input that you're checking for has its own parentheses. Each overall condition that you're checking for has parentheses, and then the whole bloody thing has parentheses. Oops, sorry, my goodness, where did that come from? Let's try that again. And again, we're going to copy and paste, partly out of laziness, partly to reinforce the fact that we're not reinventing the wheel here. It's not new functionality, it's just a reapplication. So, if A is being pressed, move to the left. If not, well, is D being pressed? Move to the right. If neither, and if there is no input from either one, now technically you could just do else and do this. I think that would work as well, because if you're not doing this and you're not doing that, therefore you're not doing either, but doesn't hurt. It's also good to know in the future for when you do have to check for a not, because sometimes you check for a not and you check for a positive. So sometimes it's a combination of a positive and a negative. So A, and it stops. D, and it stops. Space. And really, that's what we wanted. So the last thing is that if you hit this, then that ends the round. So basically, you just need a script attached to this that, again, on trigger enter, I'll go back and do it in a second, but it's basically the same thing. On trigger enter, and then load the next scene. But since this isn't part of a larger game, there really isn't anything to show you there. Lastly, there should be a force field here. I'm going to wait to see what kind of reception there is before I continue, but if people want to see it, that was the one thing that made this different from Garf, is that there was this force field that moved from left to right. So if you shot it here, that hole would move over. Okay, so if you guys want to see that, just leave a comment, let me know. Otherwise, I'll probably leave it like this because this is what we're trying to do. We were trying to make a ship that is destructible, and we'll just make one quick script for the alien. So create C#, we'll call this boom. Let's click on our, where's our alien? So there's our alien. We'll make it a trigger just to be consistent. We'll take boom, put it there. We'll open that up. And again, on trigger enter 2D. If other, if other dot tag equals equals, yes, it has to be a double equals. If other dot tag equals, it was shot, then we want something to happen. Again, I can't actually do a summary or a load new scene because this is a standalone at the moment. So this is where you would trigger the, like an explosion. This is where you would trigger a bonus, a tally, and then load the next scene. So we'll just do debug.log you win. And I think that should do it. Okay, so here's the thing. We did not destroy it, but because it has a 0 scale, it technically doesn't exist. I'm not happy with that because I'd rather have it be destroyed, but it does indeed work. So again, if you want one more video that does a few bells and whistles, just let me know and I'll do it. But because it has a 0 scale, there's no collider. But again, that's not good memory management and that's not good object management because if it no longer has an impact, it really should be removed from the scene. So again, something like this, it's not resource intensive, so it's not a big deal. But again, as far as like good game design, you would want to make sure that's actually destroyed when it reaches 0. So again, if there's anything else you want to see, just let me know. I'll leave it like that for now because it does work. We did get the you win message. And we'll leave it at that. So again, let me know if there's anything else you want to see. And I hope you found this useful, and I hope you have a good day.